12. You deposit $300 in an account earning 5% interest, compounded annually. Compounded annually. Okay, keyword. How much will you have in the account in 10 years? All right, I know we have said when we see deposit, that's a keyword for annuity. But in this case, also we use deposit. But the deposit here is not a keyword, right? Well, I'm not getting this. Deposit here is not a keyword, right? Because it's just a one time. And also it's because it's a small amount of money, so it didn't use invest. But for us, the keyword is compounded, compounded. So we know to use, something's wrong with my writing board. It doesn't write for me anymore. Try to put it back in. Yeah, doesn't work anymore. Okay, let me use my fingers to write. Oh, okay. Okay. So we compounded is the keyword. So we know to use the compound formula. And because it's deposit only one time, so we use Pn equals to P naught multiplied by 1 plus R divided by K, then raised by Nk. Now we need to identify those variables. Okay. So Pn, in our case, is P10. Do we know how much after 10 years? We don't know. We're trying to find. P naught is the amount we invested or we deposited, which is 300. Then 1 plus R, R is the interest, 5%, and 5% equals 0.05. Right, 5, so R equals 5%, which is 0.05. 0.05 divided by, what's the K? Annually, compounded annually. So it means one time in a year, once per year. So K equals 1, so divided by 1. Raised by N, or N equals 10 years. How long the money stays in the account? Stays in the account for 10 years. K is 1, so 10 times 1. So this is set up, right? Because compounded is the key word. Then we know to use this formula. We know to use this formula. Then we need to put corresponding, we identify variables, right? R is the interest rate, which is 5%. Decimal value is 0.05. And the K is how many times compounded in 1 year. Well, annually means once per year. So K equals 1. The money stays in account for how many years? 10 years, so N equals 10. Then we just put those variables in the corresponding place. Right? R is here, K is here, N is here. So now, once we put everything in, let's do the calculation. So P10 is the amount of money after 10 years, and we don't know, and we're trying to find it. Now we do step by step. So first we do this to 0.05 divided by 1, which is itself 0.05. Because anything divided by 1 is itself. Then raised by 10 times 1, which is 10. Right? Then we calculate the inside the parentheses. So keep writing this is 300. 1 plus 0.05, that's 1.05. Then raised by 10. Well, this one, we need to use a calculator. So we use these, so I'm going to use decimals for this. I'm going to stop share this, then bring up the calculator and try to share decimals calculator. Right, so I have 1.05 raised by A raised by B. So I press this button, raised by 10. That gives me this number, Can I copy this number? Oh, yes. So I can copy paste, right? Then I multiply this number by 300 because I have 300 multiplied by this number. So to get 480, no, that shouldn't be right. That should not be right. 1.05, let's do this one more time. Oh, maybe right, because it's only $300, yeah. Because it's only $300, so we round to cents, right? So the third decimal place is 8, so we carry 8 to 6, we get a $488.67, right? 488, so let's write this. So we get a $488.67, right? So this is the amount of money after 10 years. Right? So let's go back to the review. So we invested $300 in an account. The account earns 5% interest compounded annually. How much will we have in the account for 10 years? So we identify the interest rate is R, 5% with 0.05. K is compounded time annually, that means 1. N equals to 10 years, the money stays in account. Then we put the numbers into corresponding variables, right? So R is 0.05, K is 1, N is 10, K is 1. The NK means N times K, so 10 times 1. Then if we could, we can put everything into the calculator. If not, we do step by step. In the end, we get a $488.67. All right, so that's question 16. Now let's see 17. 17 is saying how much would you need to deposit in an account now in order to have 20,000 in the account in 4 years. Assume the account earns a 6% interest compounded annually. Again, we know we need to use the compound interest formula. Right. We need to use this formula. Now we need to identify which is which. So let's identify. Do we know Pn? In our case, it's P4 because n equals 4. Do we know P4? Yes. Because we want to have, in 4 years, we want to have 20,000. So that's P4, that's not P0. Do we know P0? No. Okay. We're trying to find how much to deposit now. So we don't know P0. Then in 4 years, so we know N equals to 4. And assume account gives a 6% interest, so R equals 6%, 0.06. All right, so let's put into the calculator. So we know P4 is 20,000. We do not know P0. We will try to find P0. Then 1 plus R, which was R, 0.06. Oh, we didn't identify K. Let's identify K. Compounded annually. Again, K equals 1. So divided by 1, then raised by 4. So then let's calculate. So we need to calculate this part. So P0, we still have 20,000 equals P0 times 1.06 raised by 4. Right, 1.06 raised by 4, I can do on my calculator, on my normal calculator, because the exponent is only up to 4. Mhm. So 1.06. I said multiply 1.06 with itself 4 times. So I get, so anything else I'm going to rewrite. So I keep writing 20,000. I keep writing P naught. Now 1.06 raised by 4 gives me 1.262477, right? Kept this many places. For you, at least keep 4 decimal places, okay? At least keep 4. So now what do? I have P naught multiplied by this number equals to 20,000. So I'm going to divide both sides by this number, 1.262477. So that is P naught equals to 20,000 divided by 1.262477. So let's do that. So 20,000, that's 2 followed by 4 zeros, divided by 1.262477. So I get 15,841.87 cents. After 7 is a 2, so I said ignore it. Because we're talking about money, so we only keep 2 decimal places, right? So that is for 17. So in order for me to have $20,000 in 4 years with 6% interest compounded annually, I need to deposit now $15,841.87.